Well, hello, 7th grade. I hope you're doing well. So as I talked about on Friday, we do need to kind of finish out. And so we're going to do a little quick focus on the surface area of the sphere, and then we'll move into L106. These notes should go on your L105 notes, okay? So go ahead and draw this baseball. I remember as a kid, we used to play baseballs a lot. We played them along the streets. And at some point, the baseball would either start to fall apart, or maybe we were curious and we were like, hey, what would it look like if we took these stitches out? And if you've ever done that, or I encourage you to do it if you've never done it, is what will happen is you'll have this weird ball that's like wrapped in twine and all that, but what will remain of the covering will be this leather kind of patchy thing that's made of leather, and it'll ultimately be like that. And this helps us with our concept of surface area. So if I unwrap the ball, it's going to look like that. And what I end up with is 1, 2, 3, 4 circles. So if we think about the formula for area of a circle, we know it's A equals pi r squared. And a sphere is going to be greater than that. Well, so what we're thinking about is surface area. And what will that surface area be? Yeah, you guessed it. Good job. 4 pi r squared. And so this understanding of what baseballs look like when we take off the leather covering and how it affects the formula is basically, it just kind of says that a sphere is 4 circles. Let's look at this situation. It says the diameter of a tennis ball is about 6 centimeters, and they want us to find its surface area. Now notice they give us the diameter, so we have to be careful because in the formula we see that we're focused on the r, the radius. So if the diameter is 6 centimeters, then we know that the radius would be 3 centimeters. And we must move forward with that. Okay, let's go ahead and plug in. So SA for surface area equals 4 times pi, and then we're going to plug in that 3 centimeters using parentheses squared. Let's keep working that. Surface area is equal to 4 pi, and then, so that would be times 9 centimeters squared. Hopefully you'd agree. Then I can multiply that 4 and 9 and say surface area is equal to 36 pi centimeters squared. And again, if they want an exact answer, there it is. We can give it to them. However, as you know, your book often asks for us to do something with pi. This is our exact answer. However, if they want us to do something with pi, we're going to give them an approximate. In this case, what they want us to do is name that pi is 3.14. So we'll go, okay, surface area is approximately, notice the approximate symbol, 36 times 3.14 times centimeters squared. Let's do that work up here. 3.14 times 36. And again, you shouldn't have to wait for me. Go ahead and do that. Pause if you want. But when you come back, you should come out to the conclusion that that is 113 and 400ths centimeters squared. And therefore, I could say surface area is 113 and 400ths centimeters squared, and I can box that up. This is my approximate answer. Where's my approximate? Okay, there you go. There it is. Boop, boop, boop. Yeah. All right, now let's get into L106. A new sheet. This is new notes. And it's kind of a big title. We've got 3 things to go through, but none of them are very big. L106, new sheet, please. Solving literal equations, transforming formulas, and more on roots. So let's first start with literal equations. What are they? Well, basically a literal equation is an equation that contains only variables. And so if you gave me something like this, solve for x, and then they give me the equation, which is x plus a equals b. Solve for basically means to isolate that variable. If you notice right now, what is isolated is the b, but it's asking me to isolate this x when it says solve for x. So just like before, I mean, if they're numbers or variables, we can still ask the same questions. I might say, what's happening to the x? And you'd say, well, it's being added by a. And I'd say 5 words or less. And you'd say, subtract by a on both sides. Let's write that out. X plus a minus a equals b minus a. Now, on the left side, we know we're just going to end up with x, because positive a plus negative a, it's a battle, no one wins. And then I would just write b minus a and box that up. You might go, why would we ever bother? Well, it's mostly kind of leading to another thing, but let's practice one more. Here it says ax equals b, and it wants us to solve for x. So what's happening to the x? Well, it's being multiplied by a. So what should I do? 5 words or less tells me I should divide both sides by a. On the left side, I know I'll just get the x because a over a is equal to 1. And then over here, I get b over a. And you might go, well, what does x equal? B over A. Well, what is B? B. What is A? A. Like, there ain't no numbers here, and that's okay. It's mostly just like a little skill that we're working in order to deal with something we want to do with formulas. So what is a formula? A formula is an equation that shows the relationship between two or more. What do you say, class? Count of three. 1, 2, 3. Variables. Good job. That's what a formula is. And we know several of them. Hopefully this one looks familiar to you. P equals 2L plus 2W. That's the formula for perimeter of a rectangle. Maybe this one looks familiar to you. A equals pi r squared. We just kind of dealt with that. That's the formula for area of a circle. What about a volume one? Well, we know V equals, big B H. We've been looking at that. So what we want to do with this, though, is we want to do something called transforming formulas. And that's where we basically isolate it to a different variable. If we look at our black equation, we say it's isolated to the P. We look at our green one, it's isolated to the A. We look at our purple one, it's isolated to the V. What if, though, we wanted to isolate to a different variable? So, for example, what if I had the formula for area of a rectangle, A equals LW, but they wanted me to solve for, let's say, W. Right now it's solved for A. So I'd ask myself, well, what's happening to the dub? And I'd say, it's being multiplied by L. Therefore, in 5 words or less, I'll divide both sides by L. And on the right side, I know I'd end up with just W. That's what I want. I want it to be isolated. And then I put is capital A over L. And then I box that up. And you go, well, what's the purpose? Well, there is kind of a greater reason for us transforming formulas, and it's based upon the information they give us. So if they tell me the perimeter and they tell me the width, then maybe I want to isolate, in this case, for the L. So right now, we notice that there's a couple things happening to the L. One, it's being added by 2W, and the other, it's being multiplied by 2. And I want to take the steps to get that L by itself. So the first thing I'm going to do is I'm going to subtract 2W on both sides. We said that it was being added by 2W. Let's subtract 2W on both sides. Now on the left side, look, P minus 2W, those are not like terms. I can't do anything to them. On the right side, I've got a positive 2W and a negative 2W. Obviously, they cancel out, and I'm left with just 2L. Ain't done, though, because isolation is where I have a 1 as a coefficient. Here I have a 2. So what should we do? Well, let's divide both sides by 2. Now here, I know I get L on the right side. That's good. That's isolated. That's solved for. And over here, I could simply write this, and that could be a good answer. However, if you think about it, if I focus on this 2 and 2, I could maybe arguably simplify it further by dividing everything by 2. So that would look like this. L is equal to P over 2 minus, and then those 2's would kind of cancel out, and I'd say minus dub. And these two things are the same. So either of them would be an acceptable answer. And so again, like I said, if they gave me my perimeter and they gave me my width and they wanted to know the length, it might make sense for me to transform this formula so the length was by itself. All right, let's jump into square roots, or just roots for that matter, because we're going to explore something beyond square roots. Now, if I had this question, and please do write it down, we might immediately think 5. Why? Well, we know this, that if I'm thinking about 25, what number times itself will equal 25? And we can clearly put in 5. Yeah, that's true. However, notice how it says square roots, meaning that there must be more. Well, think about this. Can you think of another number that I could plug into both of these boxes and still end up 25? Well, hopefully you know enough that you'd have to say, well, -5, and you'd be right. Because negative times negative is like signs, and we know that would end up as positive. So when they write it out like this, and they ask you what are the square roots of 25, you'd actually have to give them 2 answers, -5 and 5. But then you're probably thinking, well, don't we write the square root of 25 like that? And haven't you always told us that that's 5? I know I've answered it that way, and you've given me the box, or I put a box around it, and you gave me the right points. Yeah, I did. But here's the thing. This symbol has a particular name. It's called the principal square root symbol. And basically all that means, the principal square root symbol, principal means positive. So when we see it in symbol form, the square root of 25, yeah, definitely, you only have one answer. That's 5. However, if you see it in written form, like this, well, that's where we get 2 answers, because we're not looking at the symbol. This symbol is the principal square root, the positive square root. But if there's no symbol, well, then we'd have to answer both. hey, let's move just a little bit further into this. So this would be properly said as the cube root of 8, or the third root. Notice how there's a little 3 here. And that means the cube root. Or sometimes it's called the third root. And you might go, third root? Could there be like 5th roots and 10th roots? Oh, absolutely. But don't worry about that now. So notice how, look, when we ask what the square root of 36 is, we think about, well, that 6 times 6 is 36. Therefore, 6 is the square root of 36, and you're right. The only difference is here is with a cube root or a third root, we want to think, what number times itself 3 times will equal that radicand of 8. Start small, because it might surprise you that 2 will meet that. 2 times 2 times 2. Because 2 times 2 is 4, times 2 is 8. Therefore, the cube root of 8 is simply 2. Let's try another one. What about the cube root of 1,000? Well, we've looked at these ideas before. So notice the 3 zeros here. 1, 2, 3. Well, that would mean that the cube root of 1,000 is simply 10. Why? Well, 10 to the third we know is 1,000. So 10 times 10 times 10 is 1,000. Therefore, the cubed root, what number times itself 3 times will equal? Here's another idea. The cube root of negative 27. And you've never seen the square root of a negative, because that's impossible, really. But the cube root, is it possible? Yeah, it sure is. Because what do you want to think about? Well, what number times itself 3 times will equal negative 27? And there's only one number that will do that, and it's negative 3. Because look, negative 3 times negative 3 times negative 3. So we can count the number of negative signs. We've done that before. 1, 2, 3. That's an odd number. Therefore, we know the result will end up negative, and 3 times 3 times 3 is 27. Therefore, we could say that the cube root of negative 27 is negative 3. Yay! What a good lesson. I'm proud of you. So again, we finished up on 105B. That happened on Freya's day. So what you have for homework is HW 105, 106. So odds and evens. And yeah, that's right. I hope you're well. You can reach out to me anytime. Bye.